Hey everybody, welcome to the AI Guide where we're making AI human. What does that mean? That means we focus on the human impact of AI and the associated exponential technologies that AI enables. 3D printing, self-driving, and as we'll see in a minute, a wholesale change in how computers are used. But before that, click the links below. Get my book on Amazon, The Beginner's Guide to AI, A Short History of AI and Current Impact on 10 Different Industries. It's a fast read, a couple hours for the whole book, but it'll show you how widespread the impact of AI was even a year or so ago. Much more now. And the other link, free resources. Those resources will help you learn more about AI than we can do in these short segments and prepare you for the highly automated future that's on the immediate horizon now. And speaking of highly automated futures, today's article, also from the Wall Street Journal, it's interesting, the business press is talking often now about AI because it is seriously impacting business today, unlike 2 years ago when it was still novel. And the impact on those businesses will eventually hit the employees. Thus, the AI Guide to prepare you for that. So what did I say in a recent video? I was talking about GPT-4 and how that will, in the very near future, GPT-4 and later iterations, they're already talking about GPT-5 and 6 that are already in progress at OpenAI. This is going to fundamentally change how humans interact with computers by making things like voice command. Think Star Trek, right? But there's a next step of evolution past that we're going to talk about right now. This article by Christopher Mims, What AI Teaches Us About Our Brains. Researchers are learning a great deal about people with the help of AI. AI is helping scientists decode how neurons in our brains communicate and explore the nature of thought. This new research could one day lead to humans connecting with computers merely by thinking, as opposed to typing or voice commands. So this is, on the immediate horizon, is the switch from typing to voice commands, and then after that will be mere thought-driven computer interfaces, aka either brain-computer interfaces implanted in your brain, or they're talking about AI having the ability to read thoughts. And again, I'm thinking about the different ways this can materialize. It's most likely by implant. They go on to say, but there's a long way to go before this becomes a reality, which of course there is, because this is a second step evolution after voice commands, which is still a few years off. Previous work has shown that morally fraught concepts are the ones that people perceive in the most polarized ways. And they talk about how polarized our society is right now politically, and how people think differently about recent presidents, be it Donald Trump, Barack Obama, George W. Bush. So there's a professor named Celeste Kidd, who's a psychology professor at UC Berkeley, University of California, Berkeley. What she discovered was that even for common animals, people's notions of animal characteristics are all over the map. That means people take an elephant. Different people perceive what an elephant is and what its behavior is and what it's like very differently from each other. There's no kind of agreement among humans on what an elephant is. Dr. Kidd was able to amass a pool of data that clusters people according to which of these associations they agree on. And she came up with between 10 and 30 different clusters of human beings. Dr. Kidd and her team concluded that people tend not to see eye to eye about even the most basic characteristics of common objects. We also overestimate how many people see things the way that we do. So this explains at a concrete level the polarization in society we see today, because people simply don't think the same. Arriving at this insight required the application of a tool of mathematics that makes many kinds of AI possible, known as cluster modeling. The most important feature of AI, which enables new kinds of research, she said, is the capacity of modern computer systems to process a lot more data in the past. And we've talked repeatedly on this channel about how cloud computing and the virtually unlimited resources available now on demand brought AI into reality. Another professor, Tatiana Engel, assistant professor of neuroscience at Princeton, uses the same kind of networks of artificial neurons that are currently behind most of what we call artificial intelligence to interpret the electrical signals of hundreds of neurons in the brains of animals. She's talking about neural nets. So they build neural nets to monitor the brains of animals. Dr. Engel and her team then go a step further. They train neural networks of artificial neurons to perform the same task as an animal. And they give a few examples, but they're making they're making neural networks mimic animal brains. What they're finding is these artificial networks organize themselves in ways that reasonably approximate the ways they are organized in real animals. So these neural networks are organizing themselves to mimic the animal brains. AGI, a step to AGI. Wow. So these brains are now close enough to their biological equivalent and simple enough to teach us things about how the human brain now works. One key insight this yields is the actual substance of thought is dynamic electrical activity in our brains. So the article says in the past, they thought that we were hardwired, right? There was a chocolate neuron. There was a smoking neuron. There was a drinking neuron, whatever it is. Not true after further research. Thinking, it turns out, is just electrical signals zooming around inside our heads. What's more, AI is letting scientists listen in on and interpret the things that happen in our brains when we're not doing anything. In other words, when we're just sitting around not doing a task. This allows us to discover the internal life of the human brain. Meta, formerly known as Facebook, Meta's AI lab published research last summer on a new way to read brain activity, step toward BCI. Meta scientists used data on brain signals gathered by researchers at universities around the world. To analyze this data, researchers used a type of AI called a self-supervised learning model, which can extract meaning from giant pools of data without any instruction from human beings. Again, keep in mind, this is all almost new. It wasn't very long ago, not more than 2 years ago, that all data sets had to be labeled for an AI to understand how to utilize and manipulate the data. Now, most neural nets are self-supervised. That's an insane development in an extremely short period of time. A little less than half of the time, Meta's AI algorithm was able to correctly guess what words a person had heard based on the activity generated in their brains. So they're reading the brain patterns, and they got to where more than half the time they could tell what word the person heard based on their brain activity. Basically, Meta is trying to create a speech decoder that can directly transform our brain activity, our thoughts, into words. Imagine texting a friend just by thinking about it. So this is this decade stuff. Many people now are working on brain-computer interface. First, as this article says, and we've talked about before on this channel, will come entirely voice-driven computer systems. You will be able to do most things by voice on a computer very soon. The last holdout may be spreadsheets in Excel, because that takes quite a bit of descriptive work to verbally build a spreadsheet and get it to calculate stuff. We'll keep an eye on that one for further development. But BCI is on the medium-term horizon, which we here define as between 3 and 7 years. So, big stuff. Brain research on steroids thanks to AI. Click the links below. Prepare yourself for this highly automated future. And we'll see you next time here on the AI Guide, where we're making AI human. Please subscribe. One more subscriber puts us over 700. Share, like. Check us out on Facebook, Instagram, and Twitter also. Take care. Bye.